Retomamos neste instante a programação do Seminário Atualização Tecnológica e o Setor de Joias e Bijuterias. E um evento organizado pelo sistema AJORIO e BGM, com o patrocínio do SEBRAE, apoio da Firjan e do projeto Arranjo Produtivo Local Joia Carioca. Passamos agora à palestra do senhor Shintaro Yamaga, presidente da fabricante japonesa de máquinas Yasui, com o tema Os desafios que a indústria joalheira está enfrentando para se atualizar e se manter competitiva, o uso simultâneo das tecnologias modernas e tradicionais.
Very good afternoon, ladies and gentlemen. Thank you very much for this opportunity for the explaining a little bit more further about the casting technology. We are a manufacturer of jewelry casting machines, starting from the wax injectors, the furnace, as well as the casting machine. When we talk about casting, we see a lot of casting defect, which is gas porosities, shrinkage porosities, which is majority coming from the solidification of the metal. And when we talk about these defects of the metals, we consider a lot about the casting, which is our latest technology. But I would like to go back a little bit because the casting itself, or a jewelry manufacturing, is a very combination between a very high technology where you leave on the machineries and a very low technology where you have to apply a human labor to it. By using a advanced machinery, the aim and the goal is to have more industrial aspect to the jewelry industry and the jewelry process, as well as cutting off the human error. When we make a fabulous design, either with a CAD or handwriting designs, we will be using any kind of machineries to produce casting and polishing. However, the aim is not to rely a lot on the human labor, where we have to rely a lot on the human labor where it comes to the settings and the polishings. So I don't know whether you're aware of the manufacturing process or not, but let us review a little bit about the casting process as well as the manufacturing process. Now, as we had a very good explanations from Ms. Gay regarding the master model until filing and polishing, I would like to go a little bit more in details of how would the manufacturing process would be up to casting. After we finish the master modeling, rubber molding, and the wax will turn out to become a loss-wise casting procedure, which we will burn out with the flask and we do the casting. However, most of the productions or most of the producers will be concentrating more on the casting itself, where you melt the metal and where you physically solidify the metal. However, most of the casting defect will not be coming from the casting, but from the process, before process, that we have to really pay attention to it. So I would like to explain a little bit about, we should pay attention to every materials and the process for a better and a complete casting. Now let's start from the wax injection, what are the main or majority problem of the wax process. Most of the manufacturing process has either some kind of a wax injector to shoot the wax from your rubber mold. However, if you see these 4 stages, these are the 4 major problems or defect which is coming from the from the injection, where you have a major casting defect, which is not coming from the casting but from the wax itself. First is a burr, which is called a kind of overfill, where you have to make a reject a lot. When you have all these rejections, you have to use your hand to do it. And as I said previously, our goal is to reduce a human labor as well as a human error, because the more you retouch, you will have the weight difference along with your design difference. Plus, the labor itself, the handworking itself, will not be very consistent. Second is a shrinkage problem. Liquid to a solid, we cannot avoid any kind of a shrinkage. Using the latest technology, we can avoid the shrinkage. However, when the shrinkage comes, you're going to cast that metal where you have two major things: design loss, and the major thing is your metal loss. That's where we have to have a complete parameter settings where you can rely on the industrial part, where you can rely on the technology to reduce all these problems. That is why we consider the wax and the wax injections are as important as the casting itself. Please imagine when you concentrate on casting, in casting you will liquidize the metal and you will solidize the metal. The wax injection is the same. You use the same mold, you liquidize the wax, and you solidify the wax. So if you don't have a very good wax, it is almost nearly impossible to have a good casting without a defect. So in the production, we would like to more concentrate in the wax cleaning and the wax injection more than the casting. So to visualize in the production, we have to have all these calculations before we proceed in the casting. Plus, we would like to calculate of the labor cost along with how many times or how long will it take to reduce your defect. We would like to recommend to all the manufacturers to have a good analysis on what kind of a defect you'll be having to reduce. Either it's a machinery problem or mostly coming from the human error problems. Supposedly, like I made a case study on these two companies that majority of them is having non-fill or overfill problems where you need to have a lot of retouch work. Suppose like in these parting lines where it really affect the casting, these majority of them is not coming from your wax, but we also have to look at your rubber mold where it's as important as the casting. After you made the wax, of course, you have to make your investing and your burnout process. When we talk about investment, we just think about what kind of a brand are you using and what kind of parameters are you using. But let us just go a little bit into the basic that I would like to explain. What is a investment and investing process? The investing process is considered with a lot to do with water temperature, humidity, a powder itself, and handling of the investment. When we mix, please calculate your gloss-off time as well as your parameters. Most of the gold and silver investment, the ideal gloss-off time will be about 12 minutes. If it exceeds or if it goes faster, please consider that you'll have some kind of a casting defect. And also, the handling of the powder as well as the mixing process of the powder will influence a lot to the strength in casting. After we make the flask, we have to consider a lot also about the burnout process. The burnout is not just to make the burnout of the dewaxing and the burnout of the oven. We have to have a certain and clear step to make your investment harder and cleaner. Before we go to the parameters, I would like to explain a little bit about what is a investment powder. Okay? The investment powder is a combination between cristobalite, silica, and gypsum. Those three will be mixing, will have a chemical effect, and make it hardening. So that is why to keep all these in a dry area will be very, very important. When these three components mix together, it becomes very fragile. That is why we need to burn them out in a certain temperature to make it hardening. If you don't have the correct temperature, the flaming will be starting, as well as the fragile, which is the breakout of the investment, will be starting very rapidly. In order to hardening your flask, the ideal and maximum investment temperature will be around 730 to 750 degrees. However, we have to have these temperatures at the same grade at the same time. With these three elements, please check the below difference. What is most important for the flask, as I said, is not just hardening itself, but also to have the hardening in the flask at the same place at the same time. The reason why is basically it's a combination of cristobalite, which makes the hardening, and the gypsum, which is the glue part. If we have these mixtures and the hardening at the same time, you'll see on the right-hand picture that all the layers of the metal will be flowing at one time or evenly. That makes less problem and the less porosities in the casting. That is why if you don't have this, there will be either a gas porosity or a shrinkage porosities, which is caused by the gas kick out or the evaporation of the metal itself. The reason why to have even heat temperatures in all the stages, especially in the hardening, as I explained, the investment powder is very fragile, so that if you have too much heat into it or not enough burnout, you'll have also the same thing, which is the evaporation coming in, where you have basically a non-fill or a porosity in the casting. So that is why, in terms of casting, a lot of people are not paying attention to the burnout, where it's playing a very important and big role in the casting itself. As I explained, the importance of the burnout is the circumstances coming from the investment itself and also a unified burnout cycle, which is playing a very big role in the casting. Third is finally the casting itself. After the investment is well cooked, we again have to go back a little bit and review your metal conditions, because when most of the manufacturers intends to recycle the metal, but we need to concentrate a lot on the handling and the conditions of the metal, which is coming from the pure metal, alloy, and the recycled metal. To have all these in a good shape combination, you'll have reduced basically a oxidation of your metal, which is coming from a lot of hard spots and gas porosities, which affect a lot to your gold loss as well as your time of your polishing. If you have an alloy or a recycled metal, a carbon oxide or oxidated metal, which is either from the powder or basically during the melting process, even you have or you're mixing with the pure metal, please consider that the metal has been oxidated. The oxidation of a metal really affects the casting, not only the casting, but also the finish of your metal, especially if you're doing in white gold kind of metal or a yellow gold. When you plate it, you will not have an equal balanced color against your finished product. So that is why to keep the metal out from the oxidation will be very, very important. In terms of casting, we would strongly suggest to use a high-valued, high-vacuum pressure casting machine. The reason why is it'll have, as I explained, less oxidation completely. When you're filling up the metal into a flask with less oxidated metal, when the metal attaches or metal contact the investment powder, it makes the gas. It's basically a silica gas, where you have a kind of an oxidation, which is the gas porosities. So that is why, to keep it in a vacuum, and a certain vacuum and pressure will release the gas from the flask, where you have a perfect casting. What is oxidation? I'm talking oxidation all the time, but let us review a little bit more about what is oxidation. If the metal is oxidated, number one, the color will change. You'll have black spots, yellow spots, red spots in your casted pieces, where it reflect or affect a lot in the finished product, especially after you do the plating. When it goes more into the final product, it'll affect more and more, and you'll see more and more color changes. If you have oxidation, the melting point increases. What it means by melting point increases is if your melting point is lower, in terms of casting, the lower temperature makes a better casting or smoother surface in the casting. So that is why if you have an oxidated metal, the metal temperature simply increases, where you have to cast more in a higher temperature, where you have more risk against your metal. So basically, you can consider that you'll have more problems with an oxidated metal than casting with a non-oxidated metal. If you see on the right, the same picture as in the burnout process, this is, on the right, is an ideal metal flow, where from number 1 to number 3 will be flowing at the same time. Where you see on the left-hand side, since the melting point changes and each metal has different densities, which is not mixed properly due to an oxidation, the oxidated metal flow, as you see, number 1, 2, 3 will be completely in a different velocity. And where it attaches makes a turbulence against the metal, where you have the gas porosities. Mostly, the gas porosities will be fixed by either a laser welding machine or by filing or polishing. However, we are completely losing the metal. In terms of the porosities are not only on the surface, it's very deep from the surface of the metal. So you'll be needing either to polish very to the end or adding another metal on top of it and just cover it and polish it, which is taking time and the metal. So again, to follow all these procedures and the process completely, not only the casting, but preparation, the process, as well as the handling, will be affecting a lot to your final product. As I just explained, I'm hearing a lot in this market that is having polishing losses due to a gas porosity or a shrinkage porosities. Please consider that if you have any hard polishing problems, please consider that your metal has been oxidized, as shown on the picture like this. Now again, a little bit more on the less oxidation. Today, when the gold price rises and stays there, a lot of manufacturers are intent to have more filigree pieces. To cast a very filigrant pieces, absolutely you'll be needing, as it's shown on the picture like this, a clean metal and melting under a complete vacuum atmosphere, where you need a clean burnout also to cast a very filigree pieces. So what is the merit of good fillings? I've made 3 articles on it. One is cast with lower temperature. As I explained, when the metal is oxidated, you'll be having a higher melting temperature, and it is almost impossible to mix in a different density of the metal. Where if the metal is non-oxidated, you'll be able to cast in a very low temperature, which the filling will be good, as well as the surface of your polishing will be much, much smoother. If I can able to reduce the time of the polish, which means that I'm not losing a lot for the designs. Polishing means I'm losing metal. Not only the time, but more I polish, I lose metal. I lose metal means we're losing designs. We're losing the shape of the designs. In order to keep the designs, especially on the filigree, you need a smooth surface so that we don't have to polish a lot. In order to do that, the only way is to take care of your metal. Productivity, of course. Everybody wants to recycle the metal. We're not going to use the metal and we're going to refine it at the same time only once. So to have a better or the same condition in the casting, oxidation, non-oxidation is a must. For the production, this is what we have to aim for, is your loss, less metal loss, as well as the less human labor. This is where we can apply the industry or the industrial aspect to the jewelry production. After casting, after you do the casting, of course, in any kind of casting machine, you are melting under or with a graphite crucible. The graphite obviously absorbs the oxygen. And this also, again, makes the oxidation, which the pores of the graphite will affect a lot to do with your secondary or the next casting. So the open time or the casting which keeps under vacuum or solidifying the metal under vacuum will be very, very important for your polishing and your after process. These are some samples that we did on the casting. This is about 0.2 millimeter thick, where again, we need a very good process and the procedures against the casting to achieve a good filling and the smooth surface. And again, as a summary, not only, as I explained, not only the casting itself is important, but the master modeling, the sprueing, and rubber molding and rubber vulcanizing, wax injection, investing will be leading to a lot to the casting result. Therefore, I would like to pay more attention on the process rather than setting up the parameters or technology, where we must rely on the machine where you can rely on the machine. However, the goal and the aim is how to combine the human labor where it's a low technology, what we can say, and a high technology where we can rely on the machines. Once again, thank you very much for the opportunity, and I'll just finish it up, wind up with my presentations for the casting technology. Thank you very much.
Eu gostaria de lhe perguntar a respeito da gestão desses processos, do impacto que essa gestão tem sobre o resultado na aplicação da tecnologia. Quando você aplica a tecnologia por si e não gerencia os teus processos, não observa, né? Não tem os cuidados, você deixa o teu metal mal manuseado, você tem uma oxidação, você tem diversas falhas, né, ao longo da gestão do processo por si, que acabam impactando. Então, assim, a despeito da internalização dessa tecnologia, quais são, né, enfatizar bem quais são os cuidados com a gestão desses processos e o impacto que isso tem sobre os resultados.
Regarding the process management, when I go and see all the manufacturers, it's not that difficult, but when I see the manufacturers, I see a very less communications between the department to department, where I would strongly suggest to have a communications between each department. Suppose, like in terms of wax injections, when you receive the order, you go from the wax injection or a rapid prototyping, whatever. The manager of each department seems that they don't care of what is going to happen at the end. So using a technology is one thing. As I said, the machine, any kind of high technological machine, it's just a machine. It'll just do what you've told him to do. So how to operate the machine will be more important than just having a machine. So that is why in order to have or order to success in a better production is to emphasize all the managers or the local operators to understand what is going to happen next in the next process or what is going to happen at the end product.
O senhor acredita que o uso dessas tecnologias, né, elas estão sendo internalizadas nas empresas, as microempresas pequenas se esforçam, colocam essa tecnologia dentro de suas indústrias e, a despeito disso, enfrentam todo tipo de dificuldade. O senhor poderia enfatizar mais uma vez, só mais uma vez, essa questão. Os processos clássicos, como eles existem, a fundição, a execução do móvel, né, do modelo, do molde, tudo isso feito vai permanecer numa certa forma. A tecnologia não vai substituir alguns processos, ela vai otimizá-los quando bem utilizada. E é possível simplesmente que a tecnologia substitua a observação, a atenção aos detalhes, o gerenciamento dessas etapas, o uso dos insumos de forma adequada e bem colocada?
Okay, to answer to your question directly, whether all these technologies can replace the current manufacturing plant, the answer is no. The reason is the rapid prototyping, any kind of rapid prototyping will rapid prototype the machine. I mean, prototype the designs. Any kind of wax injectors, if you set up the parameters, it'll shoot the wax. Any kind of burnout furnaces, when you set the parameter, they'll go up to the designated temperature. Any kind of casting machines, when it goes to set up the temperatures, it'll goes to that temperature. That is what the machine is for. However, there's no machine that can make the sprue. There's no machine to decide where you put the sprue, which is very important in a jewelry process. That's where your liquid flows, either it's a wax or a metal. So if we have all these machineries, then yes, we can replace all these technologies from the current situation. However, why I said no is because in between these technologies, there's always a handwork. That's why I explained a jewelry process is a combination between a very high technology and a low technology. In terms of casting machine, when we talk about, let's say, 18 karat gold, 75% is the pure gold, and at least minimum there are 3 or 4 different kind of an alloy, which there is different density and different melting temperatures. In order to have mix, or in order to have them melted, yes, you need a technology and you have to rely on the technology. But on the other hand, how to make the spruing, how to make the tree, these should be relied still on the human labor. However, by using all these technologies, let the importances concentrating on the technology, where we have to keep training on the handwork to reduce the human error and the failure from the technology. So we have to have a good combination in between.
Okay, thank you.
Thank you.
Boa tarde, Mr. Yamaga. Muito bom ter o senhor aqui. Muito obrigada pela sua presença, uma honra. Eu tenho 2 perguntas, mas seguindo nessa que foi o último assunto, vou começar por ela. Que a gente vê muito aqui no Brasil, e isso deve ser no resto do mundo, mitos e verdades sobre o processo de fundição. Tem sempre um segredo novo, né? Qual o ângulo que você deve colocar a peça na árvore? Não, agora você bota de cabeça para baixo, você bota 90 graus, e assim vão se tentando, acho que, resolver problemas que não estão bem aí, né? O Rio de Janeiro é pior para fundir porque a umidade relativa do ar é muito alta, influencia no revestimento. Os próprios os cabos de alimentação também sempre há uma novidade que acaba nunca se tornando uma solução para os diversos problemas que a gente tem no dia a dia. Onde nós poderíamos conseguir essas referências das melhores práticas, né? Eu acho que a gente ainda está muito um pouco nessa meio obscuro ainda, né? O que é mito, o que é verdade. Como a gente poderia ter um manual aqui à nossa disposição das nossas indústrias, das melhores práticas na fundição?
That's a very good question, and I hope it's a myth. But to answer to your questions, the reason why there are so many different kind of process of manufacture is not only in Brazil, but across the world. I've seen, and I've done a lot of coaching in the jewelry school. It looks like there, as you said, there is no definite solution for this. Most of the company owners or which is doing by generations are just simply saying that, no, I'm doing my dad's way, or I'm doing my father's way. In 10 years back, when the designs had more simplicity and there was no computer aid programs, it was possible. But today, in terms of more stone setting or more filigree designs, there should be a theory, but it really depends. Suppose, like as you said, the spruing, whether it's a 90-degree angle, you put it upside down, or whether you have 90-degree angle, whatever, it really depends on your designs. Also, it really depends on your alloy. So it's better to have all these process. But before going more into the technical, I would like to go review more on the basics, where I've just explained. How should the wax should be? Before that, how should the rubber mold should be? Because in terms of making the sprue, I've seen in most of the cases defect is coming from the spruing, which we have to understand how is the fluidity of the metal to the pieces, or how would we control the shrinkage porosity. This has a lot of things to do with the spruing rather than applying a technology to it. All these theories has to be done by design to design. So the the best way to emphasize the Brazilian market for a better solution is to have like a production course, which Yasui and our distributor Colin can apply. But since there are more secrecies in the designs and secrecies in the metal of these individual manufacturers, we intend to do these consultancies by company to company. Yes.
Okay, thank you. And another question is, desculpa. Quais são as tecnologias mais inovadoras hoje existentes no processo de modelagem, injeção e fundição disponíveis no mercado internacional?
Well, in the international market, the rapid prototyping has been a great improvement in the market, as Ms. Gay said. On the other hand, what we feel is the market is too concentrated on making the rapid prototyping. The rapid prototyping, the material is a resin. Either it's more wax material or less wax material, whatever. We are now too much concentrated on what is the resolution, what machine is good. But good rapid prototyping does not lead to a good metal finishing. It does not. So that is why we need to more put a concentration on the casting after you make the after you make the design, after you make the rapid prototyping, and the process of the casting. Because there's no way that we can set the stone by a machine, or we cannot polish by a machine. It's still done by hand. So all the casters or all the producers have to concentrate on how the polishing will be easier than before. When we talk in terms of that, and when we talk in terms of more efficient way of production, still the casting will be the advanced technology in the international market. Yes.
Só para completar, mas já existem tecnologias de vácuo total, vácuo simples. O que em termos de fundição, de casting, o que nós temos de mais que proporcione uma fundição com menor quantidade de porosidades e de problemas possíveis? O que tem de disponível hoje no mercado em termos de tipos de tecnologia, vácuo zero, vácuo total, em cima, embaixo, não sei exatamente. O que é disponível hoje de mais moderno?
Today, in terms of casting machines, there are two ways of making casting. One is to use the centrifugal force, which is a centrifugal casting machine. And the other type, which today's majority for gold and silver casting, is a vacuum over pressure casting. In both ways, what is required is to have a complete vacuum atmosphere in the melting. If you have a small amount of oxygen, you will not be melting the metal, you will be burning the metal. If you burn the metal, it is almost impossible to mix. So you will have different density, if you will have different caratage in one tree, where you're just causing a problem. So the latest technology I can say is basically a vacuum pressure casting technology, where you can still control the speed of the metal to reduce the porosity.
Hello.
Yes, sir.
Boa tarde, Mr. Shintaro.
Good afternoon.
Acompanhando um pouco a pergunta da Carla, eu gostaria de saber quais são as suas avaliações ou mesmo impressões do impacto que a tecnologia 3D vai ter na fundição. Na medida que a gente saia do prototipagem rápida para o uso no metal, ou seja, deixar de ser cera e resina para usar o metal. Você tem analisado isso? Como é que você vê isso ao longo do tempo?
I agree with your idea. In the future, today's rapid prototyping it depends on the market. But suppose if we look at the Asian market, where we use the rapid prototyping to make the master, where a lot of Europeans and the American market, where we considered that the rapid prototyping is done directly into the casting. It really depends on the market, how you will process. In the large manufacturing or mass production, where you'll be still needing wax injection, where it's a very most economical way of casting. But on the other hand, if we look at the European or US market, where you don't need a mass production, but you need a quality, we also believe that is the future, which is the direct casting. Now, in terms of direct casting, we have to apply a certain different technology than wax injection casting process, which has not a lot of things to do with the casting itself, but more to do with the burnout process, how to prepare your flask. Because in any kind of rapid prototyping or 3D printing, there are two types of making in today's technology. One is more into the printing, and second is done by what we call a rapid prototyping. The first printing is simply a 3D printer. The advantage of 3D printing is there's the more wax patterns inside. It's more of wax. Where the rapid prototyping, either you use the light or the laser, is done more with the resin. However, comparing the injection wax, both have less paraffin inside and more silicone and plastic inside. No matter either it's a printing or a rapid prototyping, if we have a plaster which makes the solidification faster and harder, the burnout process and the type of investment you use will differ as a such. So if we are able to control the plaster ashes coming out from the investment, or if we know the composition of the resin, where and which temperature where they have the thermal expansion, we'll be able to control the casting. So to answer to your question, it really depends on the market, whether the market is going for more into direct casting or the market is going more for the wax injection market.
Thank you.
Yes, sir.
Um aqui atrás.
Olá, boa tarde. Obrigada
Good
pela
afternoon.
palestra. Está sendo muito
Thank you.
proveitoso. Eu gostaria de saber um pouco sobre a fundição de outros metais, como a gente tem visto uma tendência grande na Europa de fundição em titânio. Eu sei que é um processo um pouco complicado. Ao invés da borracha de silicone, usamos grafite, se eu não me engano. Gostaria de saber um pouco mais sobre essa tecnologia de fundição no metal titânio, que é um metal muito especial, tem umas propriedades que muito se adequam, inclusive, ao universo da joalheria, né, pela sua durabilidade, pela sua resistência, mas tem um alto ponto de fusão, né? Gostaria de saber um pouco mais. Eu tenho visto várias peças interessantes europeias com fundição de titânio. Obrigada.
Okay. As I just told, that there's two ways of doing casting, one with a centrifugal and one with a vacuum pressure. In terms of metal, it'll be more beneficial for vacuum pressure in terms of gold and silver, and gold with palladium alloys. We can consider that I segregate the type of casting in a degree of 1600 degrees. So if the casting temperature is less than 1600 degrees centigrade, I would recommend to have a vacuum pressure casting. On the other hand, a group of like titanium or a group of platinum, it's very slow to melt and fast to solid. At the same time, it has a very high melting liquidus and solidus point. So in order to cast titanium, if we're using the graphite crucibles, it'll just keep eating up and just burns the graphite, so it'll not able to do the casting. We have a lot of customers that is doing titanium in a ceramic crucible with a centrifugal casting. What we need for the centrifugal technology is, since it's very slow to melt and very, very fast to solid, we have to have a machine that rotates approximately 400 to 450 RPM in about 0.1 to 0.3 seconds maximum to reach to that point. Because as soon as you release the coil, the metal is already solidified. So we have to push the metal into the flask within 270 degree from the first turn. So that is what titanium is. Titanium has been a kind of a trend also in the Europe and American market, as well as starting from middle of 2000, the bridle for platinum has been a great increase in the European market as well as the American market, where you have to have a different precise control, especially on the melting of these high melting point metals. So we use different technologies for that. Yes.
Mais alguma pergunta?
Boa tarde, tudo bem, Yamaga?
Good afternoon.
Muito interessante sua palestra. Eu só queria fazer algumas considerações sobre aquilo que você falou e também uma observação sua, porque eu acho que nós brasileiros estamos adquirindo, sim, eu vejo aí as empresas todas preocupadas em adquirir essa tecnologia mais moderna para que fique todo mundo inserido aí num patamar, assim, vamos dizer, igual ao que o mundo todo está fabricando. Acho que nós brasileiros já estamos atingindo um nível assim de excelência muito bom na joalheria. O que eu gostaria que você comentasse, eu acho que toda empresa tem uma cultura de fabricação, tem um modelo e assim e todas elas conseguem tirar dentro daquilo que está acostumado o que a tecnologia moderna pode oferecer. O que eu percebo muito no nosso fabricante é a qualidade do material empregado, principalmente das ligas. Eu gostaria que você fizesse uma observação, porque a gente observa que o fabricante tem uma máquina super moderna, mas deixa muito a desejar nas ligas que são usadas dentro da sua produção, principalmente liga e também a qualidade do material, né, em si, do ouro, né, da prata. A gente tem uma dificuldade aqui de adquirir essa matéria-prima muito grande. Então, eu gostaria que você fizesse uma observação, principalmente a respeito das ligas, que eu acho que é um subproduto que tem que ser muito bem observado pelo fabricante, porque é aí que nós vamos tirar a joia, realmente, se for feito todo o processo normal, né, que a tecnologia oferece, mas se a gente não usar esse material adequado, infelizmente, a joia, no final, não vai ser o produto que a gente espera.
Ms. Brunner, I really agree with you regarding this point. In Brazilian market, comparing the other markets, such as in Asia or in Europe, this market has been using more modern and high technology, investing on from the CAD until the casting, even the polishing machines have been using a very modern technology. To answer to your question, Mr. Brunner, we are using a very advanced technology for the jewelry industry. You're using a sophisticated CAD cam, you're using sophisticated wax injectors, you are using a sophisticated casting machine, and moreover, you're using a sophisticated plating, and you are also using a sophisticated alloys. I have not seen a lot of market, such as Brazil, that is using a very sophisticated alloy. Either it's a 14 karat, or either it's a silver, or either it's an 18 karat. But when I see most of the manufacturers is the use of the metal, I believe it's not proper enough. I believe that when you produce, if you're doing for the first casting, which you will be melting the fresh virgin metal against your fresh virgin alloy, I think you will not have a problem. But when it comes to the secondary casting, it's not stable as the first casting. The reason why is in most of the casting areas or most of the places where you melt the metal, you are casting in a vacuum atmosphere. You're not preparing a metal in a vacuum atmosphere. So that is where the oxidation and deterioration of the metal starts. So as I said, what is lack from using an advanced technology is the between process. Why the metal is not filling? We would like to blame it on the casting machine. We would like to blame it on the alloy. But we should go back and check whether it's the right spruing or right tree making or right investing process. In order to do that, as I've explained in the very beginning, in each department needs a communication. In this country, the designing is perfect. I mean, I can say I've traveled about 70 countries with marketing and coaching, and either they're using a very advanced technology or they're using a very low technological machines. Where the company is succeeding is they have a communications in between the division to division. Okay, the wax shooter, even a wax shooter knows the finished product. The person who is doing polishing knows or communicates with the person who cleans the rapid prototyping resins. If we're able to do that, we can easily analyze where's the defect is coming from. And to answer to your question, yes, you are using, or most of the people are using, suppose, non-oxidated copper, a very high contamination silicon in the alloy, or a very non-oxidated zinc, or even crystal zinc, which affect a casting a lot. And here, since most of the customers or most of the manufacturers are using in a closed system where the zinc and the silicon is minimized. Why next casting, after casting, the secondary and the third casting is not good is because we are preparing the next casting mostly in a torch. So that is why your silicon gets oxidated, your zinc evaporates. Yes, the caratage rise, but you're having a problem. So the handwork, we have to be more careful on it, especially where you prepare the metal. And if we take in a lot of care on that, I think the problem can be resolved step by step, sir.
Obrigado.
Thank you.